Graphene-enhanced lubrication technologies, integrating experimental analysis and AI modeling to optimize performance across various applications. Oh.
This one goes forward. Okay. So hello, everyone. My name is Ethan Stefan-Henningsen, as I was just introduced. And today I'm going to give you guys a little bit of a presentation on optimizing lubrication and kind of where we're going with our experiments into the AI field. So to begin, I'm just going to give you a quick introduction of the lab that I'm working at Ontario Tech University. So I'm currently doing my research under Dr. Kiani's supervision at Silicon Hall, which is a part of the Ontario Tech University. We focus on lubrication, nano and nano material fabrication. We have access to a lot of different machines, laser fabrication and stuff like that, as well as some tribology testing that we can do. And so before I get into any of the presentation, I'm just going to give a little bit of a background of lubrication. I'm sure most of you guys, if not all of you, know what lubrication is for. It's meant to reduce friction, wear, and ideally increase the lifetime expectancy of different machines. But while normal lubricants are doing an amazing job at helping a lot of these machines function at high speeds, high volume, there's one area that we need to look for improvement, or that could be improved, which is the addition of adding nanomaterials. These nanomaterials have the potential to increase things like wear properties, thermal properties, and friction properties, as well as just reduce the prices of the actual grease as a whole, because if we add these additives, we can use less of it, and or have a couple of maybe have less downtime for different machines and equipment and other things like that. So my main area of research right now is on graphene-enhanced greases. For those of you who don't know, graphene is a nanomaterial, one of the first nanomaterials discovered, and we can actually use it to help enhance different types of greases. But how do we do this? So the first step that we do is we prepare different samples. So if you look online, there are several different methods used to prepare graphene-enhanced grease samples. However, there's not one clear and obvious method to choose from. During my research and my time working on the masters, we actually were able to perfect a way of mixing in the graphene into the greases. So what we would do is we get a sample or some base oil from Petro-Canada, pure base oil. I think it's grade 2 and 3. And then we'd actually put the graphene inside the base oil. Now, the reason why we do this is the graphene actually can't mix completely homogeneously inside just lubrication grease homogeneously just by itself. It needs to have that pure base oil from Petro-Canada in order to mix fully. So once we have the graphene into the pure base oil, we actually have to put it into a vortex mixer and mix it around 5 to 10 minutes in order to make sure all the graphene is completely mixed in. And then we're going to put it into an ultrasonicator. This ultrasonicator basically sends ultrasonic waves to break up all the particle agglomeration that could have happened during the mixing process. And then once that's finished, we put the grease into that mixed solution, and then we shear mix it for 10 minutes until we have one solution. Now, the good thing about this is once we have it inside of the solution, the grease oil mixture, it will stay suspended forever, or as long as the grease is good for, which is really good so that we don't have to worry about, let's say, shelf life of the products and other things like that. But once we had our grease samples created, we actually had to develop different types of tests in order to make sure that it makes a difference or an impact on any of the on the actual qualities of the grease itself. So to do that, we actually started something. We actually created a thermal test that we were able to get live data from, as well as post data of wear scars and wear depth. So over here, you can see there is the machine that we use, which is the tri-pack bearing tester. So what we would do is we take a 0.5 by 0.5 inch cube and place it onto that onto the bearing, as you can see in the photo. I wish this had a laser, and then we put a weight on it of 500 grams. We'd apply the grease onto that bearing, and then we'd start the machine. Every 30 seconds, we take a photo with the TI-32 Fluke camera. It's a thermal camera that actually is used in OPG, many OPG reactor um, teams. And we would take these thermal measurements every 30 seconds for 6 minutes. We chose 6 minutes because at that point our machine got extremely hot and it wasn't producing desirable results, or it would just mesh everything together after that. So what we actually found was when we had a 0.5% graphene inside the grease that we added, we actually had a peak temperature of 61.1 degrees Celsius, which is a 31.5% reduction in temperature when compared to the samples without any graphene in it. Now, we did notice diminishing returns in regards to the 1% and 2% of graphene content, where they kind of performed very similarly in terms of temperature, which meant that we had a clear front runner for the best optimal concentration for graphene inside these different greases. You can see on the bottom left-hand side there, those are actually thermal images that we took of some of the different samples. So you can see the darker area under the 25.1 is actually the grease that we applied. And then you can see how the temperature has increased over time. And then once we've collected all these temperature results, we actually can use that cube that we had and get the wear diameter, wear scar area, and as also the depth of the wear scar. So as you can see probably from these photos, I'm not sure if it's clear and obvious, but the 0.5 sample has the smallest area of any of the wear scars, which was actually 21.5% shallower. 21.6% shallower than the other ones. And you can also see while the profilimetry images are not as clear as the other ones because of scale, and of course you guys are a little far away, we can actually have that reduction as well. So it's clear that we are doing that the graphene-enhanced grease was making a difference. However, we still needed to run some more tests in order to prove that it actually makes a full difference. And this is where we had to get to standardized testing. So what we did was we contacted some of our industry partners, such as Petrolube in the United States. They're located in New Jersey, as well as Fluid Life here in Bradford, I believe, Ontario. And we were actually able to get some standardized test results. So we first started off with kind of your meat and potatoes test, which is the 4-bar wheel test, to get the coefficient of friction. And as you can see, the 0.5 sample actually performed the best out of all of these, which was it had an average coefficient of 0.087, which is pretty good compared to the control sample, which was 0.091. As well as the next test that we had was TGA test. Now, this test was extremely valuable for us. For those of you who don't know what a TGA test is, basically you put around 5 grams of grease onto a little pan, and then you heat it up to about 700 degrees Celsius. And you see how fast or how slow the grease itself degrades or kind of disintegrates. So what we noticed actually was when we had the 0.5% weight percent, it actually degraded at 50 degrees warmer than all the other ones. This is due to graphene creating a lattice type structure that is a lot more challenging to break down than when just a standard grease is used. And the reason why the 1% and 2% are also in line with the control sample is because of the fact that once you get too much graphene, the chances for particle agglomeration is a lot higher, meaning that when it creates this lattice, it's going to have graphene particles actually in the mix there, causing multiple clumps, and then that just makes it a lot easier for it to degrade or disintegrate at those temperatures. Once we had that, we decided to go to Fluid Life and get a penetration test. This is basically just to see that adding the graphene doesn't change the NLGI grade. So we're dealing with a grade 2 grease, and seeing this, we were able to maintain the same grade, which was extremely valuable, as well as we were also able to do a water washout test, which showing that it actually, the 0.5 weight percent sample also stayed, had the highest percent obtained when doing a water washout test. Now, all these data is good and great for us to know and to know what the best concentration is, but in many applications, you don't know exactly what you want, or you do know what you want, but you don't, let's say you don't have the funding for this type, for that amount of graphene, or you want like more temperature reduction rather than friction reduction, or vice versa. So that's where we're looking to go to in the future here. We are actually working on, or I'm actually working on making an AI model that will predict graphene characteristics of different types of greases. So let's say, for example, you say you want to put 1% of graphene into this grease solution. I'll put it into the model prediction, and then it'll give you the final temperature or predicted temperature based off of our ran simulations, the coefficient of friction at that point, as well as the wear scar and wear depth. And that's going to be extremely beneficial for companies who, let's say, they're looking for 70 degrees, for example, a temperature at this time. So they're going to know exactly where to go. And the good thing about this one is, as well, is we're doing more and more testing on different type of nanomaterials like titanium dioxide, graphene and titanium dioxide mixed. And so we can continue to increase the knowledge or the scope of the AI model, and then eventually know, like, give exact characteristics for different types of materials, and actually can optimize concentrations for any type of application that's required at that current moment. The bottom left-hand corner of the screen there, it's kind of the temperature distribution currently that is predicting. So it's not finished, obviously. It's still a work in progress, but that's kind of like the outputs of different weight percentages and different times. So that is it for my presentation. I hope. Thank you for having me on today. Does anyone have any questions or anything that they would like to know? Yeah, or no. Oh, sorry. So the question was, have we ever tried using carbon nanotubes for this application? Correct? Yeah. So no, we haven't thought about that just yet. We actually have. We've mostly been focused on graphene, and then we moved into titanium dioxide. But we actually are trying to right now kind of mix titanium dioxide and graphene is kind of our next step in our in the project. But maybe down the line, carbon nanotubes will be added in, or we'll start testing them as well.
We have Ken round question. So Ken is asking to ask a question and repeat the question.
Ken, can you please?
Sure, no
ask the
problem.
question?
Interesting. Just a quick question. What can you tell us a little about what your control grease was? And I noticed that graphene, when you mixed it in, seemed to soften the grease, which seems to be counterintuitive. Any comments on that?
So he asked what the control sample or the base grease that we used was, and then he said that the grease actually seems to be softened. The results show that the grease is softened afterwards. Do I have any comments on that? Is that correct?
Yeah.
That's what you asked? Okay. Yeah. So to answer your first question, sorry, to answer the softening grease question first, our goal is obviously not to change the characteristics of the grease. However, it is a slight softening effect, but the effects of the actual enhanced grease itself, it kind of outweighs that effect. So you're kind of giving up one thing in order to improve two others, if that makes sense. And the type of base oil we use was actually Lucas Oil's white lithium grease for this application. It's kind of was the one with the least amount of additives that we could find, because making our own like pure grease in-house is not really possible or realistic. So it was the closest one that we could find with the least amount of additives and variability in their formula.
So Steve has a question as well.
Okay. Steve, do you have a question?
I have two questions. The
Okay.
first one is you use Vertex mixer. Is that only a liquid mixer or grinder?
So his first question is, I used Vortex mixture. Is it liquid mixture or grinder? It's a liquid mixture. So we have the base oil, and then we put the graphene inside the base oil, and then we mix it. So it's in a liquid solution.
So your graphene is nanoparticle ready. Don't need
Yes.
grinding.
It is
Okay.
nanoparticle ready. So the
Okay.
graphene is nanoparticle ready. Yeah.
So your mixer just mix the graphene in the oil uniformly.
Yes, correct. Correct. Yes.
Okay, thank you. The second question is, I saw your TGA test, and at 0.5% graphene, you have the degradation temperature goes higher. Is that correct?
Mhm. Yes, correct.
What's your graphene degradation temperature if you only use graphene in the TGA?
Sorry, can you repeat that? Sorry.
I mean the TGA degradation temperature for graphene.
So so he asked what is the temperature for the graphene for the TGA tests. So the normal one degraded the control sample around 250 degrees Celsius, whereas the 0.5 weight percent sample enhanced was about 300, in between 300 and 310 degrees Celsius.
I mean, it's also that's great increase, but the graphene itself, if you put graphene in the pan for thermal analysis, is that degraded temperature, what that degraded temperature is its own?
So his question is, if we put graphene itself in the pan for TGA, what is the temperature on its own? We actually didn't run that test. We could only run the test with the grease samples. We didn't actually run the test by itself with graphene alone.
Okay. Okay. Thank you.
Okay, thank you. Yeah. No.
Something that you should try. Anybody that makes ink so there's bound to be somebody around here that makes ink that can do a commercial lab scale commercial homogenizing. That's what I'm line. Your contact with some. So they're gonna make oils.
That would be really good. Thank you.
Yeah, we have the high speed air dispersion black tech, and it's actually next. Colors together.
Hey.
There's your
There you
connection.
go. Okay.
So, question I have.
Okay.
Have you tried it less than 5%?
Yes, we've tried it up to 4%. Oh, sorry. The question was, have we tried it less than 0.5? Yeah. So the answer is we tried it at 0%, 0.25%, 0.5%, and 0.75%. So we tried in between to make sure that the characteristics changed. So the thing that we found was the 0.5% was the optimal one. Maybe like 0.6 would be better. But the more comparable one is the 0.75. So it was for the thermal tests that we ran, it was like maybe like 2 to 3 degrees more. And then the coefficient of friction, I believe, was it was on par, if it was about the same. So, but it's a lot easier for us to mix the 0.5 and it also has the same like. Lauren, do you have a question?
Yes. Now that you've understand the dispersion method and the ideal concentration in the grease, if there was, and I know there are, if someone had a grease other than something off the shelf that was minimally additized, would you be able to gain more insight? We've got Wayne Mackwood and others of us that have been involved in the grease industry and are able to put together various types of grease unadditized, and perhaps the effects would have some other interest. Is that possible in your research?
For us to, so the question was,
To take it, yeah.
sorry, what did you say? Sorry.
No, go ahead. I think you're
No,
summarizing it.
Okay, yeah. So the question was basically, can we add it to other types of greases, and then check the characteristics based off of those? Correct.
Yes, that's right.
So we have tested complex lithium grease as well with the graphene inside of it, mixed inside of it. Oh, and noticed the exact same trends as we had with the white lithium grease. But yes, this is during my research, we found that people would use multiple different type of greases like polyura grease and other types like that. I probably butchered the pronunciation of that. Sorry. Close. Okay. Probably. Okay. But yeah. But it is possible to use it on multiple different types of greases. Yes.
Okay, thank you.
Thank you.
Couple comments and questions. One, just a suggestion, reach out to HL Blatchford. Aldo Piggin.
Okay.
They make lithium 12 hydroxy. They sell it in to make preform grease. They could probably show you how to make a and you be able to then make your own unanodized.
Yeah.
I want to just reach out. I'm there on the other side of the cross.
Okay.
They're a leader in preform hydroxy.
Well,
The powder, and you add oil and you shear it. And yeah, those got a broken wing, but there'll be a pigeon again soon. The other one was my NLGI hat on here. I don't know if you were aware, but NLGI has academic research grant program. We recently upped it to $100,000 US for a research project can be over a 3-year period. I don't know if you've applied for it. It's just passed, so you'd have to be looking at the next cycle, but we're always looking for fresh grease ideas that are at least related to the grease industry. So certainly look that. And there's no, it's Canada, US, anywhere in the globe we can support.
Okay. That would be good. Yeah. Thank you.
We've given out so we just upped it from 50 to 100. Research.
Yeah. I don't have to repeat any of this, do I?
The last one though was just a suggestion is to consider Canada, not sure where the lab is, I think Michigan, is SRV. Actually, there's a test you want microscale.
Okay.
So SRV testing, you can do a lot of different part configurations, the equipment. So you might want to search that out from a wear, EP, friction, fretting wear. It can simulate a number of different things that are very related to what you're trying to do.
Okay.
I don't know if Savon has it or it was the guy, he's right next to it. He just in somebody's place. No. It's, Adams. Kind of a, oh, yeah. Maybe you can do a record win, maybe you can give me your. Yeah, I'll see if I can find you this project.
Yeah.
Because that is such a good point. The SRB would be
It really is.
really the best indicator of whether you're.
Everybody's using it. I mean, if you go to Tesla, you go to any, it's, you have to have SRB data.
Okay.
It's all about exactly what you're trying to do.
Okay. Yeah. Then we'll definitely look into that one. Yeah.
So we have a question online. It says, what is the graphene size, particle size, how many nanometers?
Are we allowed to say that? Yeah. Are we allowed to say like, because it's about 1 to 3 atoms thick. It's 20 I want to say nanometer, 20 to 30 nanometers in size. If that answers the question, I don't know if you said another characteristic or was that?
How many
It's 20 to 30 nanometers.
Okay. So I don't see any other questions online related to your presentation. Any questions at all? We have a presentation by Joran and George regarding the activities of front-end CLE section. So as we get ready, if you want to grab a bottle of water or do something,